Hi class, Assalamualaikum warahmatullahi wabarakatuh. So let's move to the next part. That is it's still the same power supply. We have learned about diode where it will change from 2 polarity to 1. So now let's learn about what happens inside the filter. So inside the filter we have what we call capacitor will be connected parallel to your load. So what is the role of capacitor? The role of capacitor to charge and to discharge by holding the voltage at inside the capacitor. So in your diode circuit, so you are going to connect it to, this is your Vs, this is your diode for half wave. You are going to connect your capacitor in parallel to your load. So this will be your load, this is your, so the voltage across the capacitor we call Vc, voltage across the load we call Vr, voltage at the before the diode we call Vs. So looking at the circuit, your Vc and Vr are parallel, so your Vc will be always the same with your Vr. Okay, so now let's have a KVL equation from the circuits. Okay, so let's say here is plus minus. When you apply a positive cycle from your Vs, this is half wave rectifier, right? So when you apply a positive cycle, means here is plus minus. So when you do the KVL, what will be the equation for your KVL? How you can do KVL? Because now you need to check diode is on or off. So at your positive cycle, diode will be on, right? So it become minus Vs, let's say this PLM1 plus V gamma plus Vc equal to 0. So what will be your Vc equal Vs minus V gamma? Your Vc here, it will be always the same with Vr. Okay, so we want to see now what is the role of this capacitor inside this equation. So now let's see slowly what will be the output from the capacitor. So you know when you're having the positive cycle, your Vs is moving, right, from one to another point. So let's have some point here. So you have here Vs, and here you have Vc equal Vs minus V gamma. So we're going to check whether your diode is on or off. Okay, diode is on or off. This is the condition of the diode. Okay, so let's start. If you apply here 1, we are going to assume here V gamma equals 0.7. So 1, what will be your Vc? 1 minus 0.7 is equal to 0.3. So now, in order for the diode to on or off, so this is your diode, this is your Vs, this is your Vc. In order for your diode to turn on, your Vs must be much more greater than your Vc because you need a positive supply here, right? So now in this condition, your Vs is equal to 1, your Vc here is equal to 0.3. So now your diode is on. So when the diode is on, your Vc will start to accumulate the charge. Okay, so let's increase to 3. So 3, you apply here 3 volt, the voltage means at this point maybe 3. Okay, so your Vc will be 3 minus 0.7, it become 2.3. Now Vs is 3, there is 2.3. So it's still on, right? So your capacitor is still charged accordingly. Okay, let's say your input of your Vs, the maximum voltage here is 3. You are given the amplitude is 3. Now, you are given here is 5. So let's increase here to 5. So now it become 5. So 5 minus 0.7 means 4.3. So it's still higher than Vc, right? So it's still on and charging. So the capacitor have, what happened here is capacitor will charge accordingly. Okay, so now if you see at your input now, your signal here, the maximum now is 5. Now at this cycle, your input will start to decrease, right? So this is the maximum. So now let's say it decreased back to 3. So now in here it become 3 again. Okay. Okay, when it is 3, you know what is the role of the capacitor? It will hold the charge. So when it hold the charge, it will maintain 4.3 here. So check, in this condition, this is your diode. This is 3, but here is 4.3. Do you think the diode will be on or off? Just now, as we said, in order for the diode to turn on, you need to make sure your Vs is much more higher than your Vc. But in this condition, your Vs is less than Vc, right? So when your Vs is less than Vc, diode will be off. So here diode will be off. So what happened during off? Your capacitor will, this means off means what? Off here means open circuit. So when it is open circuit, it will disconnected, right? But you remember capacitor, it will hold the charge and it will be slowly discharged because you don't have any connection to the input. So if you decrease again, so it will be slowly discharged, maybe 4.1, and the rest and diode will be still off. Okay, so let's draw the graph. Okay, let's say this is your input. The amplitude here is 5 just now. So how are you going to draw your output? Okay, so at this condition, what is your VC just now? Your VC just now is Vs minus V gamma, right? So your V out is actually Vs. V out or VR equal Vs minus V gamma. V out means the voltage at the load here. Means if we draw back the circuit, so you become, here is your capacitor, here is your load, here is your VR, here is your VC, here is your Vs. Okay, the blue one here, blue. So the blue one here is your Vs, the voltage at your input. Now we want to see what will be the voltage at the output. So I will draw the output in black color. Okay, in between here to here, what will happen? Your input will start to decrease, right? Means let's say just now you see here 1, it becomes 0.23, become 2.3. So it will be like this. Okay, but once it in this condition, diode will be on and the capacitor will charge. But at this condition, what will happen? Your diode will off, right? Why it is off? Why it is off? Because now it slowly go down. Your input is slowly go down here, and then when 3 is 4.3, it is less, right? So the diode will be off, and then it will be slowly discharged. Slowly until when? So in this condition, diode will be off and slowly discharged. Okay. Until when? Until when you have, say, again you have another cycle here. Until you reach the condition when your input start to increase again. So it become like this. Charge, discharge. Okay. So in this area where it will be discharged, why it is off? Because your Vs is less than Vc. This is your Vs, right? Your Vs start to become decrease. So that's why it is less than Vc and diode off. In this condition, diode on and charge. So in this condition, your Vs is much more greater than your Vc because it's increasing. But in this area, it will be decreasing and discharge until it reach the when your Vs become increase again, we charge, discharge, charge, and discharge. So this is what happened inside your filter. So on top of that, how you're going to measure the filter? So this is what we call ripple. V ripple. So what is the ripple? Is when in between the discharge until the charge point. So in order for you to measure the filter performance, you need to calculate what we call here ripple voltage. Here's the explanation. So at the positive cycle, your capacitor will charge. At the once your voltage is less than your VC, diode will be off, right? And then we will start to discharge. Okay. So This is the same circuit, so here will be on direct charge, and here between here capacitor will be off and discharge. So it will be discharged slowly by exponential here and the time constant. Okay, so how are you going to calculate the ripple? So just now, this is what I mentioned just now, the ripple. From the maximum voltage to the minimum voltage, here is what we call ripple voltage. We denote by VR. So what is VR? Is by exponent Vm, the amplitude, minus Vm exponent tau over RC. So what is tau? Is the total period from here until T prime is the time of the capacitor to discharge until it lowest value. So from point A until where it starts to discharge at the lowest value is until here. So this is what we call T prime. Tp is the whole period of the circuit. Means if we have this value, so means if we denote here from here until here we call the period, the normal period that you learn inside the frequency, right? Okay, so when you expand this formula, and then you can get this VR equal Vm T prime over RC. Okay, so we can denote T prime, we can approximate T prime is equal to Tp. So it's almost the same. The T prime is the time to discharge, right? Until its lowest value, it will almost the same with Tp. So you can denote Vm T over RC. So this is the formula. Okay. So how you can change this to frequency? You know F equal 1 over T, right? So means your VR equal Vm over FRC. What is R? Resistor at the load. C capacitor value. Vm is the amplitude. VR is the ripple voltage. So for half wave rectifier, you are having this formula. But for full wave rectifier, you're having your VR equal Vm 0.5 Tp over RC. So there is additional 0.5 here. So means if I change this one, Vm over T you bring down F, 0.5 you bring down to RC. So with full rectifier, you have extra 2 here because here is 0.5. Why 0.5? Because at your full wave, we have everything will be converted to one polarity, right? So it becomes plus, plus, and plus. So your ripple voltage will be towards the lowest value will be lesser than this is your T prime and this is your T prime. So your T prime at your full wave is half from your T prime at the half wave. So that's why you have 2 there. Okay. So how you are going to change this to Im? So you know half wave VR equal Vm over FRC. So V over R is actually Im, right? That is from Ohm's law. So this one and this one is actually your Im. Okay. For your full wave, Vm over 2FRC. So it will become Im divided by 2Fc. So this is the formula for your ripple voltage. Okay. So if we see here between half wave and the full wave, which one having a smaller ripple? Of course, it is half wave because your T prime here is much more smaller than your T prime at your full wave. Okay, because why we need smaller ripple? Because towards the end, you want to change this to a DC voltage. Okay, so we will discuss this example in the next video, inshallah. Okay, class. Bye-bye. Assalamualaikum.